Hello my dear champions, the most awaited video is over here with me today for KCET maths trick, right? So first of all, welcome all of you to this particular session and to our channel Diksha Karnataka. Today I'm going to discuss the amazing tricks of KCET, question based mathematics. Basically the tricks over here, when you start solving and going through that, you'll find it actually relevant to the questions of CET. That's why I said KCET question based tricks. Okay, so it's not like any general tricks of mathematics which is not going to be useful over here. So all the tricks becomes very of higher importance. Okay, so are you ready for it? Of course sir, you've been ready for it. You've been asking me for all the classes of 15-day challenge and before also, sir, when is the trick math video coming? And I told you was a little busy with other things going on, but now I couldn't find the time, and so I'm here to deliver the session you were all asking for. So make sure that all of you like this class, okay, because this is your request, and let me know if any doubt is there, if any problem you're facing or any clarification you need for any of the trick in the comment section. Would like to see your love and your interaction in this particular video. Okay, so I think we are ready to start now. Will not waste much of your time, but before I start, I have to ask you, if you are not following all of our class, you are missing out on marks. So please start following each and every class of ours. We have done everything on our channel Diksha Karnataka to make sure that your results for CET is going to be outstanding. Okay, whether it is theory, PYQ, KCET pattern questions, whatever it is there, we have delivered. Okay, whether it was in master stroke or 15-day challenge, we have done every bit of it. Okay, so if you have missed out, it means only two things is there. Either you are not part of the WhatsApp channel. So if you're not part, go and join there. You'll get the PDF and all the updates in the WhatsApp channel. Link you'll find in the video's description. And if you have not kept the notification bell on after subscribing, that's why you do not get to notify about the class that came towards you. Okay, so subscribe the channel and always notification on. Ready for the trick number one? Yes sir, ready for the trick number one. Have you seen this kind of question in CET? Yes sir, we have seen this kind of question a lot actually in CET, where you have partial fraction form dx upon x times of x power 10 plus 1. Sir, actually we have seen x plus 1 and x plus 2, that kind of question, sir. Why didn't you take like that? Don't worry, I have those questions also, but this is also one of the tricks that I wanted to share with all of you. So what you do over here is simply take the power as the reciprocal 1 by 10, and this is the result 1 by 10 log of x power n. The smaller part, this is, always remember, x power n will be less than x power n plus 1. Sir, how to remember this trick? Sir, how to remember this trick? Like this, check here, this value will be always less than this value, always. Okay, so x plus 10 plus, if I ask you, x power 10 is more or x power 10 plus 1 is more? Clearly sir, x power 10 plus 1 is more. So x power 10 plus 1 will come over here in the denominator, and 1 by 10 will be also here. So answer becomes option A, guys. Answer is option A. So I'm taking the trick alongside the example also so that it makes sense to all of you. Let's see the trick one more time. Okay, trick number one is done. Trick number two, let's start this question. Have you seen this kind of question? Yes sir, this comes in our boards and CET both, and the trick is very simple. This is the trick, excuse me guys, this is the trick that if you have the question in the form of 1 by x minus a x minus b, you take the difference of a b. Don't take only positive, because in this case a is 3, in this case a value is 3 and b value is how much? 7. So a minus b will be what? A minus b will be negative, sir, so that's why minus 4. And always think about it, x minus a by x minus b, so we'll have x minus 3 by x minus 7. I can use the minus sign over here, and this question becomes 1 by 4 log of x minus 7 upon x minus 3. How come, sir? How is this true, sir? Reciprocal law in the log. Okay, so we can change the power using that. So answer will become what? 1 by 4. Option is, sir, C. Trick number two, relevant or not? Let me know how much relevant you are able to find these tricks over here for your preparation of CET. Again, we have more tricks in mathematics, but they all don't apply to your questions. But I have given you the tricks over here directly related to the problem. So please follow this properly, and you will see certainly the confidence will come going into the examination. Okay. Now, are we going for trick number 3? Are we ready for it? Yes, sir, of course. Why are we making us wait? Trick number 3 over here. This kind of questions, x times of 1 minus x, whatever is the power over here that plays a bigger role, the answer becomes 1 upon n plus 1 and n plus 2. 1 upon n plus 1 and n plus 2. What's the value over here? Check this out. 6 plus 1 and 6 plus 2, this is what, 7 into 8, 56. In the denominator, sir, answer is option B. Second question, sir, here 3 is there, so 1 upon 4 into 5, so 1 upon 20, sir, option is A. Option is A. Over here the answer is B, and here the answer is option A. I hope it makes sense. Okay, so trick number 3 is done, guys. Trick number 4 already here. Another one, in the case of this, you can see the first few tricks are for only integration. You guys are scared of integration, no? I know that. So tricks will help you score. 6 marks comes from integration in the KCET. Few questions you can solve using tricks only. What more you need, right? What more you need? So trick number 4 is dx upon 1 plus e power 6x. If you have question like this, sorry, this should be 0 to infinity, guys. 0 to infinity, okay, this is not 0 to 0. How can you integrate 0 to 0? Everything will be 0 only in that case. 0 to infinity. Then the answer becomes log 2. Log 2 by 6. So option is B. The property is log 2 by A actually. So the question in this case will be what? Log 2 by 3. Log 2 by 3. So option is C. Answer is what? Log 2 by A. A depends from the coefficient of E that you have. Trick number 4 is done. Trick number 5. If you have, sir, sine mx and sine nx, some coefficient is over here, m and n. If they are equal, then you have pi by 2. If not equal, then 0. Property is, if they are equal, then pi by 2. If not equal, then 0. Same goes with cos also. Are they equal, sir? No. Answer is option A. Are they equal, sir? No. Answer is option A. Makes sense, guys? Yes. Properties, if you have sin mx, sin nx from 0 to pi, answer is 0 if m and n are equal. If it is not equal, then pi by 2. But remember, limit has to be the same thing. You cannot go in the question and say, sir, the question came for 0 to pi by 2 and we applied this trick and I got the wrong answer. Of course, you'll get the wrong answer. To apply the trick, you have to use the whole statement. 0 to pi, sin mx, cos, sin nx, or cos mx, cos nx. If this property comes, answer 0 or pi by 2, equal, then pi by 2, not equal, then 0. What about this question, sir? This I can solve in many ways. No, I can solve. Acha, one more thing. All these questions can be solved using the long method. The actual method we can use. The tricks are, just to understand the answer directly over here. In this question, sir. Okay, I think already have written over here. Yeah. Yes, this is the statement, right? Cos square is 6x as cos of 6x into cos of 6x. Okay, so I can write cos square as cos into cos into cos. In that case, please check m value, n value is equal to 6, and when m and n value is equal, what happens? Answer is pi by 2. Answer is pi by 2. So option D is right. Okay, so trick number 5 is clear, guys. I hope you had fun in this trick. Trick number 6. Tan power 8, tan power 6 is there. Sir, what to do? Interval 0 to pi by 2. Very simple trick. Whenever you have this to this, the answer is 1 upon n minus 1. What is n value over here? Compare. N value is, sir, 8. So answer is what? 1 upon 8 minus 1, which is 1 upon 7. Option D is correct. 1 upon n minus 1. Option D is correct. Okay. Trick number 7. Trick number 7. Whenever you have a sin x, b cos x, a tan x, b cot x, or what do you have? A secant x and b cosecant x. Answer is always the same. Pi by 4 times of a plus b. Always same. Apply this. 5 plus 2 is 7, sir. 7 into pi by 4 is option C, sir. Whenever you have 7 plus 3 is, sir, 10. 10 into pi by 4, sir. So 10 into pi by 4, sir. It becomes 5 by 2 pi. So A, sir. Over here, we have, sir, 5 plus 3, which is 8. So 8 into pi by 4. So 2 pi, sir. Answer is option B. So CAB is the options. Okay? CAB is the options. Please check. I hope this is clear, guys. Yeah, the trick is mentioned over here. Answer is always pi by 4, a plus b. This is for sine, when you have sin x plus cos x, because but you also have for secant x, cosecant x, and tan x and cot x also the same value. This already told you pi by 4, a plus b. They all have the same result. Okay, guys. Yes, trick 7 is clear, and it makes a lot of sense also. Very easy to solve this way. Otherwise, if you solve in the natural method, it will take much more time, but we don't have time in KCET. That's why this trick session was very important, and that's why you are all asking, because you have seen me doing some tricks and you must have remembered me, sir, you can give me some tricks. If you give me, I'll get easy marks and faster marks, because we all know integration questions are the lengthy ones. If you don't know the tricks, means if the similar question comes and if I go with the actual method, we'll take 4 or 5 minutes to solve the question. We don't have that much of time, so trick helps us. Okay, next one, trick number 8. This is the property of what? So we have seen this property, remember, e power x fx and f dash of x we have seen, right? We have seen this equals to e power x fx, but this is a property where you have e power x minus f double dash of x, yeah, plus f double dash of x. When you have this, then the property comes like this, sorry, yes, minus only, no, minus actually, yeah, because if you go about the question, right, 1 second guys, if you go about the question, if you differentiate, 1 by x will be f dash of x, and double dash will become what? Derivative of 1 by x. What is derivative of 1 by x? Simply minus 1 by x square. Okay, that's the derivative of minus f double dash of simply log x. So minus 1 by x square is there. How you write this statement? Basically, you'll write this as e power x log x minus of minus 1 by x square. Now you can check this out. This is your fx and this is your second derivative. When you have that, result is what? Simply fx e power x, so e power x as it is. Fx means, sir, log x. What is f dash, sir? 1 by x. That's your answer, beta. Answer is e power x log x minus 1 by x. Okay, that's option, excuse me, that's option A. Option is A. A very good question. We have the property e power x fx plus f dash of x. That also I have included over here, but this is very important one. Trick number 9. This is that property we are talking about. E power x fx f dash of x is answer always e power x fx. In this case, tan derivative is secant square. Answer will be what? Option B. Answer is option B. Clear, guys? So trick number 9 is clear. Last trick of integration. Okay. This is, sir, sine of x is a odd function, sir, and if you take sine power odd, this will also be, sir, odd only. Yeah. What about this, sir? Cos x is a even function. Even function. Then what happens? If you multiply even and odd, sir, even into odd is even, sir. 2 into 3 is 6, even number. 5 into 16, 18, 80 is a even number, sir. So even into odd is even. No. If I tell you even function into odd function, answer is actually what? Odd function. Sir, how? That was number, this is function, difference is there. How come, sir? Think about it. Even function, beta, means f of minus x is equals to f of x. Odd function means f of minus x equals to what? Simply minus of fx. So if you multiply here, check this out, f of minus x into f of, sorry, two different functions, no? I'll write this as g actually, right? Otherwise it'll be same thing, right? I'll write this as g. This is what? G of minus x equal to g of, like this, two different functions are there, no? So f of x minus x into g of minus x, the answer becomes actually for the even function f of x, and for this one it'll come outside, so minus f of x, this minus will come outside, right, because minus gx is there and g of x. So if you look as a whole, what is this, sir? This is basically fg of minus x is coming as minus f and g of x. Yes or no? Product or golf, whatever it is, doesn't matter. It's not fog actually. It is simply when you replace, if I want to show you without any trouble or mistakes, I'll show like this. So basically what I'm getting over here is f and g, if you operate on x equals to minus x, this becomes what? F of minus of fg. What is this? This is the result of what, sir? Odd function. Okay, so that's what I mentioned over here. Even function and odd function product is what? Odd function. So now we have established this, sir, odd function. This is not a trick actually, it is a property of different integral. But whenever you have odd function over here, so minus a to a, odd function is 0. Sir, we know this. I know you know this. I'm not saying everything, I am only teaching you, sir. I'm not saying that. Okay, I know you know this. This is property you have learned in NCERT only, but still it was important to recall that. At many times, no, the question might look very difficult, but when you look closely, it becomes odd in even case. Answer becomes 0. Okay, so that's your top 10 tricks from integration. Have a look. Yeah. Moving on to some more tricks from limits. Whenever you have this result, what is this result, sir? Whenever you have limit extends to 0 from 1 minus cos ax and 1 minus cos bx, the result is always a square by b square. Okay, so in this case, what will happen? You'll have this as 5 square by 4 square, hence what? 25 by 16. That's it. Next one, second trick in limits. If you have 1 minus cos ax upon fbx and gcx, answer is always what? Square of this value and b into c with 2bc. Over here you check. So square of what is there? So 1. So 1 is square. What about this, sir? It will be simply x into x, no? This is nothing but x into x. So we have over here the value as 2 into 1 into 1. X into x is there, right? Not visible. 1 second. This is what? So x into x only, no? 2 into 1 into 1, answer becomes what? 1 by 2. So answer is option B. Next trick, let's look. Now this is a good one. Okay, this is not a PYQ base. So previously questions that you have seen are majority of them are from PYQ basis. Okay, this is not a PYQ. This is something which is unique and different in nature. Has not been asked in the CET for last few years. But if it comes, then it'll be very difficult to solve if you don't know the trick. And the trick is very simple. If you have some bases A, B, C like this, and you have the powers always same, power x like this, and same power is taken to the whole as 1 by x, and this n represents number of terms that you have in the numerator. Limit extends to 0 is given by what? Product of all these bases A, B, C like this, and whatever is the number of term that comes as 1 by n. That comes as 1 by n. In this question, please check. You'll have 1 into 2 into 3 into 4 all the way till total number of terms is n, power of n. If you multiply all the natural numbers, is given as factorial. So n factorial power 1 by n. So the answer is option B, sir. Answer is option B. Okay. Now next trick in limits only. 1 minus cos ax upon fbx is there equal to 0. When you have this condition and you apply this limit like this, and whenever this value is a non-zero value, basically this is a non-zero value when x equals to 0, then the answer becomes always, the limit is always equals to 0, guys. Okay, moving on. Trick number 5. Whenever you have, now this is completely PYQ based only. You might have seen multiple questions on this trick. What is that? Polynomial, right? Polynomial function in the rational form. Ax square bx plus c. So what is this case? When the degree of numerator and degree of denominator is equal to what? The ratio is what? Always 1. Means in this case basically they're equal. So this is 2, this is 2. They're both, if you divide the degree, you'll get 1 only. No, their degree is actually equal. When you have that limit, when x tends to infinity, it always becomes what? A by b. In this question you check. What are you going to do? Simply take here x square common, here also x square common. This will become 2 by x, 3 by x square like that. You can cancel them. Okay. So the answer becomes what? Ratio of 3 and 5. 3 and 5. That's your answer. Okay. That's your answer. Over here, if in the same case, the previous one was degree of numerator was equal to degree of denominator. This is for a degree, okay? When you have that, we have the answer as a by b. What if the degree of numerator is more, sir? Means, example if I have to take for this part, if I have, sir, ax cube bx plus c, over here x plus c, okay, or let's say x plus c1. What about in this case? So it will become infinity, because if you take here x common, x and x, and over here also x common, you'll get x cancelled, but you still have ax square left in the numerator, and that if you put x as infinity, because limit x tends to infinity is there, so limit will go to what? Infinity. So for this kind of question, when degree is more in the numerator, the answer is what? Infinity. Answer is infinity, sir. Okay. Now similarly, if degree of numerator is less, for example, if I have ax square 5x plus 9, and over here what is there, sir? We have x cube plus 6. Again we have same thing, limit x tends to infinity. Okay, then you're going to take x square common over here. You'll take here what is common. You're going to take x square common. You'll have 1 by x left. This will become what? Equal to, sorry, 0. This will turn out to be 0, sir. Okay, so whenever you have degree in the denominator, more, this is more, sir, then answer is 0. Otherwise, when degree of numerator is more, answer is infinity. When they're equal, answer is the ratio of the coefficient of the highest power, basically the degree. So a by b. I hope this is clear. Very important, okay, these 3 tricks. Next one, derivative. Some tricks are there. This is very, very important. Quotient rule trick. Quotient rule. This, if not directly, you will keep using it many, many times. Whenever you have the function of the form ax plus b and cx plus d, okay, then y1, the derivative is given by determinant of the coefficient divided by the function in the denominator, the square. Okay, I'll repeat. Determinant of the coefficient a, d, b, c in the same order divided by denominator the square as it is in the quotient rule. So 2, 1, 5, 4. Find this value please from here. 2, 1, 5, 4. 8 minus 5, how much is that? 3, sir. 3 upon 5x plus 4, the whole square is the condition, the trick over here. Okay, next one. Y equal to f of g. This is what? This is the case of logarithmic differentiation. Okay, so you know how to take solution. Y equal to f power x g is there. Take log on both sides. Take log on both sides and then differentiate. That also is the correct method. But this is the result after that. Y1 is given by f power g. Same, you're going to write f power g. Then you'll keep g as it is. Differentiate f dash divided by f. Listen to me. F power g first term will remain as it is. Okay, outside the bracket. You're going to keep g as it is. Write f dash by f plus log of f. How do you remember it? Whatever is given over here, you'll write the same over here. G as it is. F dash by f and log of f. Log of f. Okay, so is this a question over here? What is the f value, sir? F value is sin x and g value is x. So sin x power x remains as it is. Okay, you're gonna keep g as it is, means you're gonna keep x as it is. Differentiate sin, it becomes cos, divide by sin only, because divide by f only, and log of sin x. Okay, so simplify, cos by sin is cot. Answer becomes sin x power x, x cot x, and log sin x. Okay, and log sin x. Okay guys, so this is the 9 tricks that we have dealt with. Now this is a very, very important one. This is a PYQ on this for sure. Remember this question, root of x plus root of x plus and so on, like this was given in the question up to infinite number of terms. Infinite number of terms. What is the answer we wrote? 1 upon 2y minus 1. So what is 1 coming from? 1 is nothing but derivative of x. So over here, if you have the function f, differentiate f and divide by 2y minus 1. This remains as it is. Okay, so answer is f dash upon 2y minus 1. I hope this is clear. Yeah, come on. Next set of tricks, few more tricks from complex numbers and other chapters also. Square root of 7 plus 24i. Now this is a question which has been asked in COMEDK. This is a COMEDK PYQ, guys. This is a COMEDK PYQ. It means this is not a KCET PYQ, but can be. Can you expect a COMEDK question in coming KCET? Yes, of course. Syllabus is almost same. Some questions are difficult over there, but can be expected over here also. So we cannot skip this. Okay. 24. Whatever is the number over here, you divide that by 2. If you have to find square root, how much you get? 12. Now write those two factors of 12. What are the factors? 112, 3, 4, 6, 2. 112, 3, 4 and 6, 2. Anything else? No, sir. So look for that pair of factors which square difference will give you the first term. 144 minus 1. I said difference of the squares of the factors should give you the first term. 144, check here. 12 square minus 1 square. How much is that? 143. Next you check. 4 square minus 3 square. How much is that? 16 minus 9. How much is that? 7. Take the other one also. 6 square minus 2 square. How much is that? 36 minus 4. So 32. Not possible. So take that particular pair whose difference in the square gives you the first term. So my number is what? 3 and 4. Okay. So my answer becomes what? This will be the first number. So 4 and plus 3i. Since it is a square root, you can write what? Plus minus sign. plus minus sign. Answer is what? Option B. Answer is option B. Yeah, done? Okay. Next one. Mod of z is 1. What is the meaning of mod of z as 1, sir? Think about it. Mod of z as 1 means that either it is 1 by root 2, 1 by root 2, like that, or whatever it is. If I take, and they're saying that to make things easier for me, it's a complex number, right? So why don't I take this as 0 plus I? 0 plus I. I can take this because this will be a complex number. Yeah. And what is the mod of z in this case? 1 only, because I is coefficient is 1. So square of 1 then and the root will be 1 only. So this is satisfied, sir, from here. And z is not equal to minus 1 because of this. So if you write this value z equal to I, value of z equals to I, check this out. W becomes what? I minus 1, I plus 1. Rationalize this, you'll get the answer. Rationalize this, you'll get the answer as I means W is coming equal to what? Imaginary value. So what is the real part of W? 0. If W is also imaginary value, if we are getting W as only I, what's the real part, sir? Nothing, no, actually 0 plus I. Why I took it as I, sir? Why can't take it as 1 by root 2 and 1 by root 2I? I can do that, but just to make things easier for me, I can go with this method also. Yes? Okay, so my answer is clear. Because I have the same form over here, you can see that, no? Z, it will become I minus 1 is easier to calculate, okay? It's not, I'm not saying that will be a wrong answer. If you take that, you have to calculate more, you'll get the same answer only, okay? If you want to take Z as 1 by root 2 plus I 1 by root 2. This also has the same magnitude, no? If you're not sure, let me show you. 1 by 2 plus 1 by 2. What's the answer? 1. 1. Because square of 1 by root 2 is 1 by 2, 1 by 2. Even this is going to give you the same answer, okay? But not required. We can go with a simpler approach. Clear, guys? Yes or no? Yeah. Okay. D is correct. Moving on. Okay, again some tricks on conic section, straightforward tricks. So if you are asked for length of lattice rectum, again as I mentioned, every formula in this chapter is actually a trick. Formula based questions comes in CET. If you know the formula, you'll get the answer very quickly. But still, if you have difficult forms given like this, then how would you find the length of lattice rectum? And for that we have, what is this represents? Coefficient of, if you have y over here, the formula is what? Length of lattice rectum modulus will be given by modulus of coefficient of y in this case upon coefficient of x square. Y coefficient is how much? 1, and over here we have minus g upon this value. Take reciprocal, you get the answer as 2u square cos square alpha by g. Okay, so option is A. Again, can be expected, okay? Can be expected. Length of lattice rectum of this condition, where you have here y was the subject, here x is the subject. Again, what are you going to write? Same value, 1 upon coefficient of y square, so 1 upon A. What are you writing over here, sir? This is nothing but coefficient of x, whatever is the magnitude, the subject over here, so coefficient of x divided by coefficient of y square. Please check. Yeah. Option is, I wrote no 1 by A. C is the answer. Previous one, the answer was A. Over here, the answer is C, sir. Okay. So I hope you are able to find the questions little bit interesting, some fun. Okay. Yeah. The equation of the axis of parabola. What are you going to do in this? Simply keep y as a constant and differentiate. You'll get what? 2x minus 4, 0, 0, minus plus 0. Okay. Same equation, you're going to get what? X minus 2 equal to 0. Answer is option C. So to find the equation of the axis of the parabola equation is given. What are you going to do? Go in this method. Here you go. Differentiate given equation with taking with x taking y as a constant. So x minus 2 is the answer. Option C is correct. Next, okay, so that was all actually. That was all in the tricks of this session. I was going in the loop, so I thought there is many more. But this is the end of your trick class. Trick applied in KCET maths, okay. Don't worry, this is the end of this session right now. If I can find more tricks which is applicable to KCET maths, I'm gonna come up with those class again. Okay, but as of now, please follow these tricks. Bacha, if you are not satisfied that sir can you give more, of course we know that, because if we can get 60 tricks for 60 questions, sir, good for me actually. But what happens, it doesn't work like that. And you remember, I've given you tricks in every question. Wherever something is required to make the process faster, I've given you tricks while solving the problems. So that's why my sessions are very, very important. Okay, because these tricks were direct answer trick. Means if you know that these tricks, you get the direct answer within seconds. But I have given you more and more tricks in my classes. That makes my classes very, very important. So please attend my classes regularly, follow my sessions. If you have a requirement, again put it in the session, in the comment section. I might be late, but I'll deliver it. Okay, that's all in this class. I hope you are satisfied, you're happy now with this session. I'll see you in upcoming classes, and keep working hard, keep smiling. Take care. Bye-bye.